Hi, my name is Sébastien Cossin and I'm going to present our participation in the multilingual information extraction of the CLEF eHealth 2020 challenge. We are a team of medical doctors specialized in medical informatics. We are working at the Bordeaux hospital in a unit called IAM. It is where the name of our system comes from. And we are also part of the areas research lab at the Bordeaux University. I will start by defining important terms that I'm going to use in this presentation, then present how IAM system works and how it was configured and tuned for this CLEF challenge, and finally a slide of discussion. Important definition taken from the article of Zetlin that you have in reference. A term is one or more words that represent a concept. A concept is a cognitive construct built on our perception. A terminology is a catalogue of terms that designate concepts in a specific domain. Abbreviation is a shortened form of a word. Lexical variant is different forms of a word that occur due to variation in spelling or grammar. Synonym is a term with the same meaning as an other term. And annotation is the tagging of words to assign them to a concept. Semantic annotation is the process of finding mappings between text chunks of a document and the concepts of a terminology. There are two general approaches, termed concept matching approach, also known as dictionary lookup, and approach based on machine learning models. The problem was formalized in the Soldeni article that you have in reference. In input, we have a terminology and a document. The terminology consists of a set of string S called the dictionary and a collection of concepts. Each concept is mapped to a set of string. A document can be represented as a sequence of tokens. The task consists in finding the set of elements composed of a pair. The first entry is Dij, which represents a sequence of tokens, and the second entry is Ck, which is a concept. In a dictionary lookup algorithm, we try to use the set of string S from the terminology to find the sequence of tokens in a document. The difficulties rely on the fact that the terms in the dictionary won't match perfectly the sequence of tokens in a document because of the following reasons: abbreviation, lexical variants, typos, synonyms, stop words, and discontinuous words. Many dictionary lookup annotators had been developed. Jovanovic made a comparison of the available tools in 2017. The tools can be tuned in several ways, making it difficult to compare them without a specific context like a shared task. Our algorithm IAM system is a dictionary lookup algorithm that we developed in 2018. It handles at the token level approximates string matching, abbreviation, and stop words. It is fast and open source. The dictionary is compressed in a tree data structure. You can see here 5 terms and their corresponding ICD-10 codes, and below how they are stored in a tree for fast lookup. Each token in the tree is a node. Given a document, the first steps performed are normalization and tokenization. Then the algorithm tries to map each token from the document to a token in the tree sequentially. In this example, the first token is ins, and it's matched to the token insufficient with an abbreviation match. Then the next token is cardiac in the document, and it's matched to the cardiac token in the tree with the Levenstein matched. And finally, the third token is aigu and is also matched to aigu in the tree with a perfect match. The fourth token is distress and it's not matched to any token that follows aigu. So the algorithm stops and goes back to the top of the tree, and then it matches again the trace with perfect match. So in this example, the sequence of tokens ins cardiac aigu, DIJ, is linked to a string in our dictionary, insuffisance cardiaque aiguë, which corresponds to a concept, I59 code. For CodiEsp's corpus, 2 dictionaries were built. In run 1, we only used the annotated terms from the training set, and in run 2, we added the terms from the ICD-10 terminologies. We manually created a list of stop words after automatic comparison of annotated terms and ICD-10 terms. No list of abbreviation was created. Some terms were removed from the dictionaries because they hindered the performance. For example, the term renal was annotated 2 times by the human expert, although it appeared 67 times in the training set. For each term, we calculated this sample ratio, the number of times it was annotated by the algorithm over the number of times it was annotated by the human expert. If this ratio was greater than 2, then the term decreases the precision more than it increases the recall, so we removed these terms from the dictionaries. Also, we calculated a simple score for each term to order them because it was important for the mean average precision metrics. The score is the term frequency in the document D times the number of annotations in the training set. The idea is to rank first terms that appeared frequently in the training set and in a document. Concerning the results, we achieved better performance in subtask 1 to annotate diagnosis than in subtask 2 to annotate procedures. The reason is that for procedures, the frequency of concepts made of discontinuous words was greater than for diagnosis, and our system cannot detect them. We had a problem with subtask 3 in the official run because IAM system didn't output the correct format of the end position expected by this task, and it was fixed by adding 1 to the end offset position of each predicted terms. In our opinion, the task was more difficult this year than in 2018 for coding French dev certificates. In comparison with 2018, the F1 score was lower, the text to annotate was longer, and there was discontinuous textual evidence, often very complicated to detect, and there were fewer human annotations. The proposed dictionary approach has significant limitation. Mainly, it can't detect discontinuous words that represent a concept, but is very fast and could be integrated in a NLP pipeline. Thank you for your attention, and don't hesitate to contact me if you have any questions.